Welcome. My name is Christopher Zug. Unfortunately, my colleague Greg Schleusner couldn't be here. He actually he pulled a hamstring training for his marathon, so he's fine, but he was unable to travel. So I'm flying solo today. Just to talk a little bit about me, I work for a company called HOK. We are an architecture and engineering company. So I am a licensed architect. My job, my official title is a design technology specialist. And what that really means is I'm kind of the guy that has to solve the really sticky problems, mainly around interoperability between the tools that we use. We're big BIM users, so obviously we're architects, so we're designing things in tools like Revit. And we don't really touch the geospatial realm all that much. So this is kind of new to us. We've kind of recently discovered FME and kind of recently made this jump into the GIS world. So this is coming from kind of an outsider's perspective, right? What does an architect need to know about geospatial? Well, other than our buildings are located on Earth, there's not much we have to do. So just to go real quick here. That changed? All right. We're, like I said, I work for a company called HOK. We're basically, we're probably the second or third largest architecture firm in the world right now. So we're located all over the world. I am working out of our Philadelphia office, Philadelphia, Pennsylvania, in the U.S. And I work closely with our New York office as well. We're in, oh boy, that wingdings is going to look really good here, huh? Lovely. All right, well, don't worry about that. There's not much reading that has to happen anyway. This is just a kind of talking about how we're basically in all market sectors. We do everything from skyscrapers to airports to stadiums to hospitals to jails and courthouses, pretty much every sector out there. We work, personally, I kind of work in our urban planning division, which is, I'm very close with that group. I also work in our aviation and transportation group. So you're going to see a little bit of that. Our very first task, for FME, so this is kind of an introduction for us to FME, is we had this big challenge. Does anybody know this airport? This is LaGuardia, right? If anybody come through LaGuardia to get here today? It's pretty horrible, right? It's a terrible airport. We are actually designing the terminal expansion here, and one of the things that we need to do is we don't really have a tool because it's such a large complex. There's no good way for our BIM platforms to actually visualize all this data or even place it in a site context. So we started looking at tools like Infraworks, Autodesk Infraworks, and a few others. And one of the first challenges that we had was we needed to see this thing in context. So this is about 4 years ago. FME, New York City itself thankfully provides a lot of open source GIS data that we could access, and this is before they actually provided a 3D model. So we used FME to actually kind of process that data to kind of generate the 3D model you kind of see in the background there. This is actually a rendered image from 3D Studio Max, but all that data in the background and stuff was generated via FME at the time. Now, of course, you can get that model for free from New York City, but at the time we didn't have it. So I'm just going to talk a little bit about, kind of data and why it's important to us as urban planners and urban designers. There's really two types of data that I see. It's mainly the data that we use, that we generate all the time, so the data that we make to plan the cities that we make, and the data that is coming from sensors or from anything else that's out there. So we're pretty good with the first half. The second half of kind of taking that sensor data or taking real-time data and incorporating that back into our designs is one of our big goals. We're not quite there yet, but we see tools like FME as the way to get there. So, all my big quotes are not here. Basically, this is talking about the pretty much 90% of the data that's ever existed has been generated in the past 2 or 3 years, right? So there's a tremendous amount of a tremendous amount of growth that's happening on the data side, and it's really important for us to get there. This cryptic message says that basically, pretty much 60% of the world's population by 2030 will live in an urban environment. So it's quite important for us to actually design and plan these things in a useful way. This is a picture of the city of Lagos. Lagos will have 24 million inhabitants directly in the city. So it's an incredible challenge to properly house and plan and make these cities actually work. So, and we also know that, the quality of life, really, the quality of the city really has a lot to do with your quality of life, about how happy you are. So if we create an environment that's happy for people or that's functional for people, generally everybody's a little bit happier. So that's kind of why we do what we do. But I just want to give you a little overview. Let's see if this actually plays. Will you play? Please. Oh, that's just lovely. Oh, wait a minute. Maybe I just wasn't on the hotspot.
Could you mime it?
I could act it out for you if you want. Well, essentially, let me just try one more thing. Let's see if we can just get this thing to actually mirror instead of be duplicate only. Sorry about that, guys. I should have used my own laptop, but I wasn't thinking. Nope, that didn't work. Try one more thing. I guess we're going to have to extend it. Okay, all right, well, it might not work here. So,
If we play it, we can probably drag it over.
oh, okay. Let's see, can we get,
Once we get started, so
well, it's embedded in
Oh,
the-
it's embedded in
Yeah,
it.
it's embedded. So if we can, wait a minute, watch this. Let's try and play it here. There we go.
There.
It's playing. Now let's see, can we drag it over to there? Oh, you're so close.
Try hold the Windows key and hit the direction you want to go.
There we go.
Okay, there we go. All right, I can't see on my screen now, so and I'm using a stupid little finger mouse here. So anyway, well, this is basically what this is talking about, is how we design
I'll try
cities.
getting it back to the beginning while you talk.
Thank you. It, essentially we start with, either we have a greenfield site or we have an urban infill site, and we have to deal with topography, we get some satellite imagery, we design the, we kind of develop a site boundary, we work with satellite imagery, then we start laying out the transportation network, so the primary roads, secondary roads, and what they look like, how they function, and then we get into, the kind of the zoning or the, what we call the transects, the land use of each individual parcel. We develop what's called a smart code, and I'll talk about this in a second. And it's kind of a different way than traditional zoning, if you're familiar with it. It's more about not telling people what they can put where, but how they can build it, or kind of the limits on the site itself. So we'll go through that in a little bit. Well, I'm going to bring it back again here so I can get it over. Just give me 1 second. We'll leave it over there, I guess, right? So let's keep going. Next slide. There we go. The problem is, it's a kind of a neat way to work, but, our tools are really a lot like this. They don't talk to each other. We use a tool called Revit. We use a tool called, obviously Autocad. We have some GIS data that's floating around. We've got satellite imagery, whether that's coming from Google Earth or something else, all kind of mashed together into like InDesign or Photoshop to make a giant book. As much as I keep telling them they like to call what they draw, drawings, but they're really making maps at the end of the day. When you're talking about urban planning, the scale is so large, we're really talking about maps here. So they don't, sometimes they listen to me, sometimes they don't. So we start with the sketch, things come in like this. We get a lot of designers are just working on trace paper. I'm going through our process now. Then we start getting into Revit, right? So this is actually a Revit image, kind of montage with some satellite stuff. These guys have no idea, most of our designers don't have any idea how to geo-reference something to get a geotiff to come in and everything. So there's a lot of manual work before we got involved and before we kind of really understood what we were doing. So this is probably just a hodgepodge of Photoshop and some Revit images. Now, again, Revit is a tool for designing buildings, not for urban planning. So we kind of abuse it a little bit. What you see, those little splashes of color, are actually rooms. So they're giant, giant rooms, thousands of hectares big or acres big. And what they like about the kind of room tool is that it does give them live data. So as they're moving boundaries of districts, they're getting updates on square footages, and we can assign some attributes and some parameters to these things. So they're getting some information. So to them, it's better than using just plain AutoCAD, because they're getting and dealing with polylines, because they're actually able to kind of attach some data to these objects. But again, in architecture speak, they're technically rooms or spaces. which causes some problems. So we design these things based on a transect system, so T1 through T6, T1 being rural, T6 being your urban kind of area here. So we'll kind of, this is the kind of the first block out. Then we'll go through and we'll kind of develop these codes based on those transects. So as you can kind of see to the left, that's a sectional view of what these buildings could look like. We may have some target percentages about like whether it has to be an office or it has to be retail or it has to be residential, but we don't tell people directly on the lot what they can build, right? It's basically, if no one else has built enough retail, then yes, you're welcome to do it. So it's kind of a different way of thinking of it than traditional zoning. So it's kind of it's not so much a new concept, and it's nothing we've come up with. It's actually it's been around for a little while, and it's called Smart Code. If you want to look it up, it's pretty interesting. But you can see it starts to talk about how the frontages work, and how the setbacks work, and what the different kind of life of the city, what it could possibly be. Whoops, went too far. Oh, great. Go back to this guy. There we go. Yeah, but I got another video. I'm sure it's going to, as long as this is big enough that you guys can see. I mean, not like you can read anything anyway because the fonts are all messed up. And the same thing goes with road types. So when we're designing these primary, secondary, tertiary, quaternary, whatever, fifth level, sixth level roads, we kind of develop multiple sections on what these things look like. Primary roads might have transport on them. They have a certain type of lanes. They have markings, bike lanes. All these things kind of are developed as part of the Smart Code. Now, and then we get even deeper into developing social infrastructure. So that's like your police stations, your hospitals, your administration buildings, town halls, city halls, cultural centers. So we even get into the point where we're locating these types of things. And again, this is just another type of room, right? So it's another room that's in there that we draw in with some boundary lines, and it has some data attached to it as to what it is. Now, the cool part is we start to get into, our clients want to see what these codes, what kind of city will generate, right? So we don't know because it's not built, and we're not going to fund it to be built or even to mock it up. So we use a tool called CityEngine to actually kind of drive, based on these transects, based on these codes and the smart code that we developed for that particular location, to drive the massing, to see what the city could look like. Does it work? Is it too dense? Is it not dense enough? So in the previous phases, we'd always do this manually. So all those kind of images down there are manually, but that's the kind of example of what these quadrants would look like. So on a T6, you see you get to more tower area, all the way over to T1 or T2 and T3, where it's like kind of single-family dwellings over on the side. So what's nice is CityEngine allows us to do that, and we'll try to play this video. Hopefully it'll play. There we go. I'm doing this from extreme angle. So this is kind of what we get. So we can develop it based on the quarter, kind of the city, like a neighborhood. We'll go through and we can play with these different parameters and actually feed these in and say, all right, well, what would happen if we made all this T6 or we made all this T4 or we made all this, high-res zone? Maybe it's a special district. All this stuff can be done. What you're seeing is happening in real time. Like if you just kind of enter parameters and kind of iterate through thousands of different options to see, are we doing it right? We don't know if that's actually going to be what the city's going to look like, but we know that our code allows that, so we better be happy with it if it happens to actually work out that way. Now, sometimes they want us to get a little bit more deeper into the nitty-gritty, so we'll go to that level. CityEngine allows us to do that as well. So, we can kind of actually literally model out the primary roads and the secondary roads and show them what those sections look like with the trees and the boulevards and the cars and all this other stuff that goes in there. At any point, we can kind of swap things out. And all of this is based on underlying data that's coming from other sources, and that's where FME comes in. And so we're going to look at that in a second once this is kind of done playing. But you can see it's pretty quick. It's pretty iterative. The city I'm kind of showing you now, I can't tell you where it is, but it's well over 1 million buildings that we had to model. So it's pretty big pieces of data that we're dealing with. So at the end of all that design process, this is kind of what we end up with. We end up with tables in Excel, or we end up with use kind of maps, right? This is technically a drawing, but it really is a map when it comes down to it. So all that data kind of gets put on top of there. Now, the problem is, none of this stuff, what you've seen, these tools don't really talk to each other. CityEngine doesn't talk to Revit at all. Maybe it talks to Autocad. You can bring in a DXF or something like that, but not in a useful way. And that's really where FME kind of ties everything together. So, and even with Infraworks. Infraworks is one of those tools that we've been using lately because it's one of the only ones that can visualize such a large set of data for us and be able to kind of smoothly fly around it and render it okay in real time. So again, so how do we connect all this? We have Revit land use plans, we've got some CityEngine massing that's kind of based on that, and then we've got this Infraworks model. Well, really the whole kind of conversation comes down to this incredibly confusing graphic, but at least the text worked. So, we have Revit, like I said, and we have kind of CityEngine, and we have, a lot of times it's Civil 3D, or we'll get a DEM from somebody, or, we have some kind of base information. All of it has to go through FME. So FME helps us generate stuff from Revit. It helps us generate things that CityEngine can use to help generate the massing, which then goes back into FME, which then converts it to IMX, which then goes out to Infraworks, all while keeping in the same coordinate system. So that was our big challenge. Just getting things lined up was huge for us. And this is where, kind of sold us on FME. So we've kind of gone in whole hog, and we're doing some actually other interesting things as well that some of my other colleagues that are here are going to talk about. I think Dave Baldacchino's got one on Friday that I suggest you see. So anyway, I'll go in a little more detail about what that's actually doing. So on this side, well, there was a couple images here that were in sequence, but we'll just talk about it. So to go from Revit to FME to CityEngine, CityEngine has this really neat ability to use graphical information underneath, so raster-based information to drive the rules that we create inside of CityEngine. So in this case, what I'm doing is we're literally taking out of Revit, so either via IFC or via AutoCAD, depending on what, how detailed they want to get or how much data they actually attach to those rooms. And we're just taking a hatch pattern. Basically, if it's a room, I'm taking out that bottom section in FME. And then, well, let me see if I can delete this final graphic so we can see the actual workspace. Delete that guy. So yeah, so basically we're taking either the hatches from Revit, and then we're going to add some attributes to it because they don't always apply, right? So like things like what transect they are. Sometimes like it comes out on the layer, sometimes it doesn't. Sometimes I'm matching things up by color. FME is very good at that, right? So as long as you've got some kind of key that can match things up, FME can do it. So we're setting colors, and then we're raster sizing and creating a geotiff. So the geotiff, thankfully, is geolocated. And when we bring that into CityEngine, we can literally say, all right, well, if you're this color gray, you're going to be T6, or if you're this color gray, you're going to be T3. And that kind of starts the whole process, and from there are rules inside of CityEngine that say, all right, well, if I'm T3, I can only be 3 stories, I need to have setbacks that are X, X, or X, somewhere in this range, and I'm going to be 50% residential, 50% retail. So all that is driven initially, which is nice, just inside our land use plan, which that already blew their minds that they could do that, our urban designers. So they were quite excited about that. But we also have roads that we have to deal with. Roads are generally, when urban designers are working on roads, it's center lines, right? We're just drawing a big center line, and sometimes it's a big graphic like that, like the dash line we just saw in the last thing. So we have to add some information to that to make it useful. So we take the center lines, and either they're exported out from Revit, which Revit does right to AutoCAD, or they're drawn in AutoCAD, or they're coming from Bentley or something like that. We add the attributes that we need. So even for our case, we don't need a lot of data on that. We just need to know how wide it is, and if we have any information about what type it is, like a primary A, B, or C. So if we have that information, we can use that. And then we just use a simple shapefile, because CityEngine can read shapefiles pretty well. So we bring that in, and then CityEngine will literally, you saw the roads there, we'll set the right width, we'll set the sidewalk width, and we'll even, if we have information about whether it's a transport road or a normal kind of boulevard or something like that, it'll apply those rules to it. So it's quite useful. So again, this is something we would have to do very manually if we didn't have FME to actually add these attributes to it. We'd have to literally make sure that they put things on the right layer or export things out. So it was kind of a simple way to get the actual roads there. Go to the next one. And then once we have all these buildings generated, CityEngine allows us to go out to FBX or 3DS or even a file geodatabase, but file geodatabases are quite slow for us, so we weren't able to use that. I mean, I see a lot of people shaking heads. It's an ancient technology. So we didn't have a lot to deal with. But what was nice is FME allowed us to kind of take each one of those 3ds models, and CityEngine can either export it as a giant mass of a model, or it can be individual properties, individual lots and buildings. And so what we do is we do it as individual buildings, and then this is the simplest workspace we ever had. It's basically converting FBX directly to IMX buildings. We're not even worried about terrain at this point. They can be in flat land inside of CityEngine, and then once that IMX is created, if we bring it into Infraworks, it'll drape it on the topography that we already have, which is kind of nice. So that was a pretty simple one. But again, there's not too many tools out there that can write an IMX file, so we were excited to see FME to do that. And then lastly, I talked about those land use, those rooms. They're really just, we use them for coverage areas in this case, because in Infraworks, you can kind of apply a shape file and apply some color to it on that end. So, you know, even if we have it set up really well in Revit, it doesn't always mean it's going to match up exactly the way we want it to look in our other tools. So just exporting this stuff out, we went from, I believe these are Revit Rooms, we extracted the lower polygon and turned it into a shape file. While adding these attributes. I mean, this is a mess of this is when I was very early on, so I'm much neater now, my workspaces. And we can certainly share this stuff if anybody wants to contact me at the end. I'll be glad to share what we've done in more detail. But we also have these designers, they'll model up the little specialty buildings. Like if they have a building they really want to do and they don't want CityEngine to generate for them, they'll actually create little masses inside of Revit. So we have to get them into the final model. So how do we do that? We use IFC. So we're basically exporting out of IFC using building element Proxy. We're off, in this case, I'm just offsetting because we don't really have a geo-reference location in Revit. You can get one, you get one survey point, but that's it. So if you want to have multiple, it's very, very difficult to deal with. So we use an offsetter to actually make that change for us and process that and get that thing at least in the relative right location as we go. And then we write them out to buildings in IMX in this case. Or, you know, we have to, I'm going to try to hide that and then undo. Watch this. There we go. So a lot of times what we do is they've kind of built these little library up of kind of preset buildings that they like the look of, and they don't know how to write the CGA code that CityEngine needs to build those. So we'll kind of instance them in. So they gave me a huge library of Revit families to kind of process and be able to use into CityEngine. So what we did was, of course, we reached for FME again. And what I was able to do was kind of bulk read these things, kind of filter out any duplicates that we have, get the coordinates for them. So because sometimes they're positioned not at 0, 0, and I need them to be at 0, 0. So get that information, offset that if it does exist so that it comes to 0, 0, and then spit out a whole bunch of OBJs for me. Because in CityEngine, if I Control-Z that, we can use those directly in the workspace and write rules to insert them at, like, well, in this case, like this is, you can see that blue triangle and that kind of extra lot right there. Basically what I'm doing is I'm finding the largest rectangle in there that can possibly fit. I'm giving 50% of that to parking. The other part, I'm saying somewhere in this thing, put a random point and place that building. So that's and place the building that I want. So you can see I have 5 or 6 different administration buildings. So as you hit the random seed button, those things can kind of alter its position, alter the building itself. So it was kind of nice to be able to write that right into the rules and not have to manually place all those buildings. So when you have 300 or 400 fire stations to put down, you know, it just happens. It's not always perfect. I mean, there's some manual tweaking that still has to happen. But at the end of the day, you know, we need to have a graphic that kind of looks like, this is what our clients really tend to like, is a big graphic like this that they can actually navigate. This is a live, well, obviously not this image is, but this is from our Infraworks model that we delivered of one single section of this massive city. So there's only probably, there's 7 or 8 zones. This is probably 1 or 2 zones together, put together. And what's nice about this is that it is interactive. We can publish this to the web. So this is a little bit of an older project for us, so the technology has gotten a little bit better. But you can see there's like there's some of that is massing, some of that is manual buildings that have been placed or adjusted. And, you know, we can do little little videos like this that really help sell it. I mean, of course, this isn't a polished one. This is just something we do really quickly just to get an idea of what things look like. But we can send this information off to our renderers to do a really, really flashy presentation if they want. So what you're looking at, again, is a combination of basically CityEngine massing, Revit land use stuff, the center lines from Autocad that we got, all developed and draped over the topography that was either from, I think in this particular case, we actually had Civil 3D, but we can use a DEM as well. And we've actually used, FME to create a DEM for us because that's the only thing CityEngine will read. So if we want to see that topography in there, we can't use 3D contours. They can't be DWGs. We actually literally have to create a DEM. And I had no idea how to do that until we had FME. That DEM generator really came in handy for us. So we were able to kind of extract the points out and make a grayscale image that CityEngine could use. So I know that was a lot, and I think I went through very quickly, and I'm sorry about our font issue. So I bet you watch this. If we do the next slide here, you won't even be able to get my email. Oh, no, it's there. Okay, so you can certainly email me with questions, or I can take, obviously I'll take some questions now, but if you want any more like kind of detailed information about how we did this, because there was a lot in there, and those workspaces were much more complex than what I'm showing, but I just wanted to kind of say that it is doable. It's really the only way we're found that we can work and provide our clients with enough of an idea of how a city might look without killing ourselves, and doing all that manually, because that in the past we've done. We would manually model up sectors about the size that I just showed, and it takes ages. So, yes, with that, I'll take some questions, and if, anybody? Sure.
What sort of plans what is the model entire cities?
Crazy ones. No. Usually, for urban planning projects of that scale, it's usually state government. So we're talking, major countries. It's a good fee for us to do. But they expect a lot, and they want to see multiple options of things. So, typically we have to provide 3 or 4 options. Generally, we would never have it in our scope to do something that large and have that many options. I didn't show all the different options, but we did about 3 or 4 different options. We would do a much smaller representation of the city, and we would do it manually. But what we found is through this process, our designers kept wanting more. They want to see more. They want, especially the senior leadership, because they really love this stuff and they live and breathe it. So to be able to see what they think the code is actually going to do or what it could possibly generate was a big deal for them. So, but yes, it's usually fairly large clients that we have to deal with.
Does Revit deal with projection?
None. No. So a lot of times we have to reproject with FME to get it even close. And that I had to learn about projection. I had no idea. I'm an architect. I don't know anything about projection. So we learned the hard way of how those systems work, and we got some help from Dale and the gang to actually make that happen. But even so, there's only a few of us that even understand that it's an issue. So trying to tell people like, no, you have to work in this point. We've set this point up. You need to work in there. If we have a civil engineer on board, that usually helps because we'll let them control where the actual control points are going. But even a project like LaGuardia, the PA, we had major issues because the Port Authority of New York and New Jersey's origin point here is in Maryland. So it's super far. And it's something to do with, they always want a positive number or something like that. So we actually have 3 or 4 different coordinate systems on this project. And just getting things to line up using Revit is pretty difficult. So we have control models that help push things, and we publish coordinates to each individual. There's actually 75 Revit models that link this whole thing together to actually make that thing work. So it's a challenge, no doubt.
I think we're going to.
Oh, I'm sorry, yes?
Is it to have
Yeah,
counting down?
yeah, I'll be here. Yeah, I apologize for going long.
So now we've got to move on to, I believe, Reed Whittington.
Thank you.